All right. Hello. So tonight I've actually picked probably one of the most boring topics to go over, and it's basically SPF, Dkim, and Dmarc. Typically, it's one of those things that normally you don't have to deal with until it's usually like set in place, and typically until a marketing department basically creates an email campaign, doesn't tell anybody, and everything gets quarantined, and they blame security. And you guys are pulled in basically to relearn everything over and fix where they goofed up the process. So, I mean, up front, email is it's a dated system that's worked great for years, and we've just built these security frameworks on top of them, basically retrofitted these frameworks together. And they are three separate frameworks, but the last one, Dmarc, sort of pulls in and ties the two together a little bit and adds a little bit more bolt on top. And to start off first, initially there is, who am I? Name's Nick Weber. Currently work at Red Canary on corporate security. Hobbies are love smoking meats and cheeses, nuts, fish, stuff like that. Love technology. A dad and a tech enthusiast. So start off basically SPF between the big thing. Sorry, look at my notes here. I have not practiced this, so you're getting it raw. There's a lot of confusion. I think a lot of people are familiar with the words Dkim, SPF, and Dmarc, and a lot of times they're not really sure what each one sort of does. And so I'm just going to break down really at a high level what they each do, how they work, and how they all sort of interact together. Out of the gate, there's basically SPF, which is basically the sender policy framework. And all it does is basically it verifies the authentication that the sending domain actually is authorized to send the email on your behalf. And what it typically does is you create a DNS record, and all three of these technologies are dependent upon basically DNS as a communication back to the receiving email server to collect the information to verify it. And so if on your domain, on your DNS, you'd put a SPF record out there and it looks similar to the one here. I can't read my example. But basically, up first is a version, and then you have either IP or it'll be DNS. And at the end, you have all basically, which is you can have recommendations what to do, basically, to accept, reject, stuff like that. There is a limitation where with DNS, there is I can't remember if it's 10 or 12 off the cuff, records you can have in SPF. So the unfortunate thing is a lot of companies now have a lot of third-party companies from Marketo to SendGrid doing these email campaigns. And if you get more than 10 or 12, a lot of times you'll get a big warning that your SPF record's out of validation. There are third-party services, or you can create a script yourself, or different ways to do it. Basically, but you can have basically a service or a script that basically goes through and reaches out to all the DNS servers for the names, basically grabs all the IP addresses and flattens them on. It's called basically SPF flattening. And it's one of the ways basically to get around basically if you have more than 10 lookups on your SPF record. But very simply, here's an example basically where the SPF record comes in. So the email comes in and it comes from Amazon. It goes to the Amazon domain, looks up the SPF record. The SPF record then goes through, looks which IP address is there, and then it authorizes and says, yep, this email is good, and come in. SPF is great. The big problem, I don't remember why I had this example, so we'll just skip it. This means basically the email can pass SPF. The thing is the email can pass SPF regardless from the from address is fake. So you can have a fake from address that's only going to verify that basically the mail server was authorized to send on behalf of that user, even though the from can be anything in the world. Next, we actually have Dkim, which is domain key identifier, and it's basically authentication protocol. Basically uses asymmetric keys, but basically will hash the email, and it'll take the headers. It'll create a hash of the headers, and it'll actually then encrypt it actually with its private key. And I'll hop to the next screen because I'll go through a couple pieces here. In the actual, so you create a DNS record, and actually once you receive the SPS, there's a couple things in here to talk about. Is one, the V is a version, so you can make it be backward compatible. That's why they put the version in the response to SPF. Then you have the encryption, which actually encrypting the header, the signature itself. And typically nowadays it's a SHA-256 encryption. You have the method of how to fetch the record, which is basically the Q value. The C is the cannibalization algorithm. Basically, this says, when an email gets forwarded from one person to the other, a lot of different mail servers can capitalize, add white spaces, remove white spaces. So this basically goes through and says, what do you want to do with basically spaces, text wrapping, capitalization? The two important ones here is basically the domain and the tag. This tells you which domain do you go to find the record, and the tag is actually the value you look up in the domain where the actual key will be stored. T is basically just timestamps, basically, so you can set the timestamp when the signature expires. Then the other two important ones is actually the BH and the B. The BH value actually is the whole body of the email. So when an email basically is sent from mail server, the email server is going to go through, look at the body of the email, and create a hash of the body of the email. And then it's also going to go through and look at the headers, and it's going to create a hash of the header. It's going to encrypt it. It's first going to create a hash, and then it's going to encrypt it. And the reason why it does the two pieces is when a receiving email basically receives the email, it's going to go through, and it's quickly going to look at the BH value, because hashing is a lot faster than encryption. So it's going to basically receive the email, it's going to run its own SHA-256 and look at the hash and compare the two hashes from the BH on what it generated itself versus the BH in the email. If the two match, what it's next going to do, it's going to reach out to the DNS server of the domain from the D value, and then go to the S value and grab the public key and download the public key. It's then basically going to decrypt with the public key the B value and get the basically hash value of the headers, and it's then going to compare the headers that it generated versus the one that came in the email. And if both those basically end up to be equal, it's going to say this email wasn't altered in the path, and this is the actually valid generated email. The last piece actually, and I don't know if this one has an example, is actually the length value. Typically, you don't add the length value because it's going to say, hey, use the whole email. And the problem is I think they should just get rid of this value. Some people would say, oh, I want it to be a little bit faster, so they'd only say do 20% of the email. The problem is do the first 20%, and then there'd be the information down below would be basically modified. You never know it was modified. So typically, you want to do the whole email and not worry about the length. This is basically another process where I'll walk through the process a little bit. So sending email server basically creates hash of the email headers and uses the private key to encrypt the hash values and adds that to the outgoing message. The receiving mail system starts the Dkim verification process. First, the version number needs to meet the Dkim specification. The identity of the sender's domain must match the I value, which is basically the domain. And then the H tag contains the from header field. Once the signature has been validated, it fetches the public key from the D tag and the S tag. The public key decrypts the hash, compares the hash. Then the mail server creates its own hash from the email and compares the two. Basically, that's how the Dkim works. So Dkim's nice to ensure that an email originated from the original person and wasn't spoofed in the process. There's one big problem with Dkim is Dkim only confirms the message was through the signing domain's mail server and was not modified, not that the message originated from where it came from. So the problem is right when these came out, these are two separate technologies. I think Dkim was made by Yahoo and Cisco. I think SPF initially came out. I don't know where it came from, and it was where the RRC originated from. So a little bit later on, basically, there was still the problem between the two. They figured out is another technology that could bolt on the two to button these two together, and that's going to be Dmarc. To actually verify the domain, in the from header. So in an email, emails are MIME formatted. So you have the envelope, which is actually the from. Just like if you have a regular letter, if you take the content of the letter, which would basically be the message, and you take the header information, that would be the information that gets put inside the envelope. And the outside of envelope is going to be the from and to. So the from and to have to deal with mail routing and how a mail gets from point A to point B. The headers and the actual content have nothing to do with mail routing. It has to be more about basically email scoring and the actual content itself and validating that the email is actually a valid email. And so with that, Dmarc controls what happens if, so Dmarc sort of says, what happens if a message fails SPF and Dkim? And this is where it sort of buttons the two together, saying, if a message fails one of these two, how do we deal with it? It also adds one extra feature on top, which is we'll talk about here in a second, which is going to be called alignment. So quickly look at some of the Dmarc tags. Dmarc has a lot more tags. First is the p-value. Basically, it says, what should I do with the email if an email doesn't meet Dmarc? Typically, a lot of people in the setup, they said p equals none. Basically says, even though if you fail it, just deliver the email to the person. This is where you can start adding things like reject once you get your Dmarc record up to where you're not going to block emails. The percentage is what percentage of the email message the subject is filtering. So a lot of times when people are moving into the Dmarc, they may put a small percentage just to make sure that they're not basically sending a mail campaign or a big mass campaign into people's quarantine buckets. The other one is the ASPF and the Dkim. And these are one of those areas where a lot of people don't realize when they're putting a Dkim, they're like, well, I want it to be as secure as possible. So they go in there and they put the value to S as basically strict. And what strict Dkim means is that if my mail address is at therealweber.com and my mail is actually delivered from mail.therealweber.com, that'll actually fail a Dkim check because it's strict. It needs the exact domain to match. So that's where a lot of times I've had problems with this where things aren't working, or I get called in to find out, well, our Dkim's wrong and we need to actually go to relax mode. And then there's the RUA, basically, and these are the reports. So one of the nice things about Dmarc is a lot of mail servers, well, the major ones at least do it, is you can set up a report actually to send back to an email of your choice, and it'll actually report back saying, I received these emails from your domain, and they either passed or failed Dkim to let you know how it is doing. So a lot of times if you're emailed like 365, Google, a lot of the other big like SendMail, Adobe's, Marketo, and all the other mail services, a lot of times they'll send reports back to let you know the status of where mail's going, what's going on, who's failing, what's going on. So the first thing, which is really nice about Dmarc, is actually what they call the Dmarc alignment. And it refers to the relationship between the domain in the from header to the domains and the associated SPF and Dkim authentication check. So the bottom part is actually part of the envelope itself. This is part of the mail routing. So what Dmarc does is Dmarc will actually go up and look at the from domain. Then it'll actually go up in the SPF record and look at the domain and make sure that those domains match. It'll also then go look at the D value in the Dkim to make sure that the domains match. And this is this is one part of Dmarc known as domain alignment. And this is the piece where you can get in areas where if you have a strict alignment, say my example here where the D value was mail.sample.com, Dkim would fail on this for the alignment check on the Dmarc record. So with this one, here's an example. Would this email pass Dmarc or fail Dmarc? Any guesses? It will fail Dmarc. The thing is, it will still get delivered because you have P equals none. So I'm not saying to do anything with it, but it will definitely fail. And the reason why it will fail is we are using strict on the alignment on Dkim and SPF. And if you see the emails, actually the from address is sample.net. And then if you look at the return path, it's eu.sample.net. And similar for with the Dkim. So this one, will this pass or fail? Nope. Right. Oh shit, it is the same. It is the same. You're right. Fail. So I have not gone through this deck since I created it, but you're correct. This is supposed to be a pass. It's supposed to be a relaxed example where it actually goes through. So you're 100% right. This would actually fail again. So the question is, what the trick here now is with Dkim was what would actually cause Dkim to fail? Because I'm missing stuff. There's supposed to be a page there. Oh, well. So did I miss one? There's supposed to be an image in there, but it doesn't matter. I can explain it. So how Dmarc's going to work is Dmarc's actually only needs alignment or SPF to pass on Dmarc or on Dkim or SPF. So you can have SPF alignment fail and Dmarc alignment pass. Dkim alignment pass. I'm stumbling over words now. Dmarc will pass. And vice versa. So what it comes down to, so the only way to have Dmarc actually fail is if you have a Dkim alignment or a Dkim check the actual signature with the hash value and the SPF alignment or the SPF check fail. So there's an and in the middle, and the other two are options. So if one of the two first fail, and the second two of the SPF and Dkim fail, and both of them are fails, that's finally one. So that's what I'm saying. Dmarc is not it's not an awesome solution. It's the best we have in this scenario of how it sort of works. And even if you get through an email through that actually passes Dmarc and passes Dkim, the problem is after that, and I didn't want to have a good example, is another thing is basically there's no silver bullet. There's what's known as Dkim replay, basically. And there's an article, actually, if you Google, Proton Mail actually had this. It's been a little while now. But basically what you can do is you can create an email from original source and then modify it, create bad content, and keep sending it through the mail server so many times that it keeps generating new Dkim. And what happens is it starts generating a trust value. Then eventually you can send that email out to a third party, say Google, and then Google will actually think it's a legitimate email because it trusts the Dkim value at that point. That's the Dkim relay pack. But that's all I have. If you have any questions. It's informational at that point. It will still deliver. It depends. Some products, I don't know which one specifically. Some products, even the delivery report will actually say you'll get the delivery report back, and it'll say that it's failed. So you get a failed delivery report. It'll still get delivered to the person. It's up to that mail server product filtering thing if it decides to do anything with it or not. No, because that's where you have replay. Absolutely not, because I've had one actually recently where someone is using PayPal to send requests, and they put comments on the send request. It actually passed everything, but it was truly a phishing email. Yes, absolutely. This one? Samuel Jackson? That one? Okay. All right, that's all I got. Was it on? Okay. It doesn't really pick. Basically, you can only have one of the two even set up, and as long as it's set up right, Dmarc will pass. So, where do you pick to choose which one's aligned? So, the alignment's basically based off these values. So, say this email did not have Dkim. The Dkim value was even there. You didn't set up Dkim. You just sent this email to SPF, and you have Dmarc and SPF set up. This email would pass. Yes. So typically you set up SPF and you set up Dmarc, and then you let Dkim run on top of it. Also, you can add in Dkim too, or you can tell it what to do. So typically you say, like, hey, reject the email, and they realized it wasn't working, so that's where they said, let's put this next technology on top they built, which is basically Dmarc. It says reject the emails and stuff like that. Yeah, I'm not 100% sure if I understand exactly, but yeah, if stuff has failed, like a lot of times you can have more than one Dkim value too. Like we actually use different Dkim values for different campaigns. So we have like a SendGrid Dkim value and all the other people. Because the problem with Dkim is it's actually an asymmetric key. So the mail server has to have that private key local. So that's why typically if you use multiple email campaigns, they have to generate that key and they have that private key local. And then they put the public key out. So that's where, here's my example, sorry. That's where the S value goes to your domain, and you'd create a new record there for that Dkim and put and advertise their public key there. But like I said, you could not even have Dkim or have Dkim completely blow up and still pass Dmarc as long as your SPF is in place. Yeah, it is. Until there's a new technology made to completely replace SMTP, we're working with like piecemeal technology. Typically, I don't touch this until something happens and... Oh, the junk mail? I've actually been pretty good. Yeah. All right. Thank you.